So let's look at body temperature and the normal model. Assume a population mean body temperature of 98.2 degrees Fahrenheit with a standard deviation of 0.7 degrees Fahrenheit that follows a normal model. In what interval would you expect most people's body temperature to be? Well, let's look at the intervals here. Between -1 and 1 standard deviations, 68% of the data is expected to fall. Between -2 and 2 standard deviations, 95% of the data is expected to fall. And between -3 and 3 standard deviations, 99.7% of the data is expected to fall. So most people will fall in this interval. 99.7% of the population of the data will fall in between 96.1 degrees and 100.3 degrees body temperature. Let's look at the second question here. What fraction of people would be expected to have a body temperature above 98.6 degrees Fahrenheit? So the first thing we want to do is come up with a z-score. So we're going to use our z-score formula. Z-score equals particular data point minus population mean divided by standard deviation. So z equals, well, our particular data point here is 98.6 degrees minus population mean, 98.2, divided by standard deviation. So 98.6 minus 98.2 is 0.4. 0.4 divided by 0.7 is 0.571. So our z-score equals 0.571. We go over to our chart, and our z-score chart, and we match up our z-score with a percentile. So we're going to look for 0.571. That's going to give us 0.7157. And remember, we're going to move the decimal over 2 places to make it a percentage. So here, the fraction of people that would be expected to have body temperatures above 98.6 would be 28.43, because this percentage, right, if we move this decimal over 2 places, the 71.57%, or almost 72%, that's how much is here. But we want to find out above, so that would be how much is below. We want to find out how many people have above that temperature. So we're going to subtract this from 1. We're going to say 1 minus 0.7157. That will give us 0.2843. Move the decimal over 2 places, and that comes to 28.43%. Let's go on to the last question. Okay, below what body temperatures are the coolest 20% of all people? So what we're going to do is we're going to find 20% in our z-score chart. So we're kind of looking at the chart backwards here, and we're going to see what z-score that 20% gives us, negative 0.84. It's negative because it's to the left of the mean. So we're just going to plug this z-score into our z-score formula for z, multiply each side by 0.7 because we're solving for y, which is our particular data point. Okay, so 0.7 times negative 0.84 is negative 0.588. Going to add 98.2 to both sides. So 97.61 equals y. That's our individual data point. Went right here. So below what body temps are the coolest 20% of all people? Well, that would be what occupies this space here. So below 97.61 degrees Fahrenheit would be this part of the curve.